Drill as the last few. Please just put a post in the chat if you have questions, and I'll take my purview to ask the first few. So a first question for you. This was mainly about what you can prove and the limitations in terms of the proofs. Have you used this in, model data and also beyond model data, maybe real data to do, covariance estimates? And do you have kind of rules of thumb now in terms of when it works, when it doesn't, and how are those different from the theorems that you prove in terms of when they work, when it doesn't?
Yeah, that's a great question. We explore some real limitations. Like here we have infinite buffers. In reality, you have finite buffers. This all works surprisingly well. It seems like very abstracted and kind of too much assumptions, but in reality, it works. In the paper that I mentioned that we were inspired at the beginning, they have a bunch of simulations with more real data.
Mm-hmm.
Um, it so it's in most cases that it works and in some cases, yeah, it doesn't. But you need to. It's not really about the type of the traffic being real, but when you go outside the hypothesis of the theorem, it doesn't work. As long as you have some traffic that is reasonable enough, that is reasonable to approximate with a Gaussian process, it really works. It's
Interesting.
that's what
So,
I think.
so it is, so the kind of Gaussian process approximation is the crucial piece, and the dependence results are maybe a little bit tighter than necessary for the real data. Is that a fair summary, or?
So yeah, the Gaussian is of course is the key to proving anything here, uh, but it's not as restricted. It really works with real data as
Okay.
long as they're close enough to
So
Gaussian process that
as
are
long
nice
as they're
enough.
close enough. And then my second one is around kind of using this on the control side. So, I mean, there's many reasons you might want to know this, but one that I find particularly interesting is kind of the feedback to this, to a policy that would maybe use this information to decide how to schedule or how to do resource allocation in some way, and maybe be doing this uh, live as you're updating your estimates. Have you looked at that? Are these results strong enough that maybe one could even prove something about an integrated policy?
Um, Possibly yes. Like if things change slow enough, you can do this on some sliding window or something that's more continuous. I think because this looks a lot like an open loop policy.
Right.
But you can actually make it continuous. You're continuously estimating, especially when you can do it in one go. When you have this solution that you can do it in one estimation, then you can do it continuously because you just are estimated over your last optimal routing matrix.
Yeah, that
So
result in particular sounds really appealing for maybe building a scheduling policy around, or something like that. Do you think that there's promise there?
yeah, especially in that case, you can most likely do it online and with feedback and adaptively to changes. Yeah.
Very interesting. Uh, Very interesting. Okay, so I don't see a note in the chat, so I'll give everybody one more chance here while I pause for a couple seconds, and please put a ping in the chat if you'd like to chime in with a question. Okay, well, in that case, thank you, Martin. Very, very interesting work.
Thanks,
Uh,